Okay, we're going to take a look at some rules of logarithms, and the directions say to simplify each expression. Now, we've already talked about in previous videos that a log is an exponent, and we can think of it in terms of saying it names an exponent. So if I'm asking what log base 3 of 3 squared is, then what I could just say is we could let it equal, let's say, the letter y. We could let it equal a variable. And then if we find y, then we've actually figured out the value of this expression. Okay, even though it looks like right now we're solving an equation, we're just finding the value of the expression. So let's do this. Let's go ahead and rewrite this logarithmic equation in exponential form. Okay, so the base 3 remains a 3. A log names an exponent, so there's the exponent y. And then I'm going to write the argument, which is what it's equal to. Well, it doesn't take a rocket scientist to figure out that this y has to equal 2. So y is equal to 2, which means this expression is equal to 2. Okay, let's take a look at the next one. We have a natural log, and that's a natural log of e to the 6th. So now I'm going to go ahead and let that equal a variable. Let's just say y. And we know, just recap a little bit, we know that this really is a log with a base e. If I really wanted to rewrite that, this is what it would look like. I could rewrite that this way. Right? And let me highlight. This right here, okay, natural log is just this. All right? So if you are a very visual learner like I am, then this might be a real great way to look at these, because then I could rewrite this in exponential form really easily. Okay, so let's take a look. We have e to the y power is equal to e to the 6th. There's the argument, right? Well, again, it's very easy to see that y has to be 6. So this expression is equal to 6. All right, so then if you want to go ahead and begin to memorize the pattern, then you can do that, but at least you know why it's happening. So this answer is 2 and this answer is 6. All right, let's take a look at another couple. All right, so let's take a look at a couple of rules of logarithms: the product rule and the quotient rule. So the product rule says this, that if I have a log and I'm trying to add to another log and the bases are the same, then I can actually rewrite the expression as the log of the product of the two arguments. Okay, so here's my m and my n, and then here they are right here. Okay, so you notice that I went from log written twice to log written one time. Now you can see how later on down the line, when we begin to solve logarithmic equations, this would be a handy thing to have, right? If I have a bunch of words, if I have log a bunch of places and I have a variable somewhere, then I would obviously want to get the log words off and whittled down, and this is a great tool in order to do that. So let's take a look at the quotient rule as well. I have log base b of m minus a log base b of n, and you notice that the bases, the bases have to match on this quotient rule as well. So then we get the log of the quotient of the two arguments, m over n. Okay, and again, the base we keep the same. Let's take a look at three examples where we can utilize those rules. So it says write as a single logarithm. This is what the directions would say, something similar to that. Write as a single logarithm. Let's take a look. This right here is my so-called m, and this is my so-called n, and if I just follow the pattern, then it's quite simple. I'm just going to write it just like that. Okay? That's writing it as a single logarithm. And again, now this is okay that this is a natural log, right? It just means that the base is e. So we're just saying that, hey, when I write my answer, it has to be a natural log because it's a base e. So this would be natural log of 4x. And a lot of textbooks will use parentheses around the argument, and just to make it clear where it starts and stops. And this last one. What I'd like you to notice about this last one is that this is very different than the other two examples, and that's because we have these numbers here at the front. Okay? So I want to introduce another property, rule of logarithms, and let's take a look at that one. Okay, sorry about that. I'd actually forgotten to write the power rule for logarithms, so here it is. Let's take a look at it. The power rule for logarithms says this: if I have the log with a particular base and a particular argument, okay, and I happen to have a number at the front of that log, I'm actually allowed to bring that number, okay, that factor, around and make it the exponent for that log. Okay, there's the argument, and again there's the base in the same place. So I'm allowed to bring that around, and it's only because a log is an exponent. Okay, a log is an exponent. And so let's take a look at what this really means. Looking down at this one here, I'm allowed to take this 4 and make it the exponent for that argument. Now, why in the world am I doing that? Because I actually have to have the log, I like to call it clean at the front. It has to be clean at the front. There can't be anything right here, nothing right there. And so I clean it off. I have to have it clean in front of the log in order to use my product and quotient rules. Okay, so I clean off in front of the log, and then I can write as a single logarithm. So let's go ahead and do that last step then. Let's go ahead and do that last step. There we go. So now I have I'm gonna write log, one time, because we're writing it as a single logarithm. So I have 2x minus 1 to the 4th times 15 to the 7th. And that's writing it as a single logarithm. Okay? All right, so a couple of more examples and we'll be through with this video. All right, so let's take a look at this last part. Write as a sum or difference of logs. So all we're going to be doing is just going in the opposite direction. So let's take a look. If I have the log of a product, then I can rewrite that as the sum of two logs in this way right here. Log base 2 of p plus, notice I'm inserting the word log again, right, as a sum or difference, because if I have product, then I'm going to have sum. All right, let's take a look at this next one. Quite simple. Log base 8, 2 minus log base 8 of 11. Okay, if I have division, I have subtraction. And let's take a look at one more that is a little bit tricky. You just need to remember how to write rational exponents is all. So let's take a look at this one, and this is a common log, right? We don't have to write the base 10 when we see common logs. So we have log of the square root of 5 minus the log of 8. Now, we're not finished. So what we need to do is we need to remember that this is really a rational exponent sitting out here as a 1/2. Okay, whoops, let me move that equals over here. So I have log, I have the common log of 5 to the 1/2 power minus the common log of 8. So in the same way that we brought the factor up to an exponent, we can bring the exponent down to the baseline, and that's what we want to do when we're expanding. Okay, so there's that, and there we go. And thanks for watching. Look for part 2.